Hello, I'm Shivam and thank you for the opportunity. So for this proof of concept, I selected intelligent customer signal detector. The objective of the solution is to identify customers who may be at risk and help a customer operations or a retention team decide which customer needs attention first and why. So here the main idea is to combine multiple customer signals instead of looking at each signal independently. So here the problem is the signals are scattered. The support charts, the billing, the customer satisfaction scores, the users data, they live in separate systems and nobody looks at them. The team reacts after a cancellation request, but they can't prevent it, and manual review doesn't scare. So this is the architecture for the customer signal detector. So first we have the CSV file. This is the 1 minute. So first we are taking the input from the CSV file. Like if we go through the CSV file, we see it has both the structured data and unstructured data. So we have the attributes such as plan, we have 10-year months, we have monthly spend, we have users trend. Like here we can get to know whether the users trend of the customer is declining or if it's increasing over the months. Here number of tickets, the support tickets raised by the customers, the last customer support customer satisfaction score, the overdue invoice, and the support transcription. Now these transcriptions are actually captured, so whenever a customer calls for any problem, so this transcript actually captures the main important lines, like the customer is saying that the export feature is still broken and they are considering cancelling, and then we are adding a scenario tag which will be checking later. So here the main component in my architecture is the sentiment engine. It's not the main component, it's the major component. So the sentiment engine's responsibility is so first of all, the sentiment engine is going to be worked both in online and offline mode. So for the online mode, we are going to use a API key, and for if the online mode is not set, then there is a fallback mechanism. We have lexicon based scorer that runs fully offline. So here we can see I have deployed this app. I have using Streamlit. So here it's running in offline fallback because the API keys I have to push. I did not push it through the secrets and all in Streamlit, but I'm running it locally here. So here we can see it is running locally and it says LLM powered cloud API. So yeah, so this is the so what the sentiment analysis does. So the sentiment analysis is the first major engine. Okay, now the responsibility is very much specific. It is going to analyze the customer support transcript and it's going to determine the sentiment expressed in that interaction. Like whatever the transcripts we are producing here, it's going to analyze this. So but again it's not going to decide whether the customer will churn. Okay, so it does not calculate the final risk score. It simply converts the unstructured customer language into a structured signal, and the rest the system can use. For example, this is a transcript where the user reported the export feature has to be broken for a month and threatened to switch providers. So this is going to analyze the text and produces something like the score, the label, and then the key issue. And yeah, obviously sentiment itself is not enough. We need other factors also. Now let's actually go through the dashboard once. Okay, so let's refresh. Yeah, so these are the total. So this is a dashboard. So it says the total customers currently in the CSV file, the critical risk, the high risk customers, the average risk scores. So here we can get that, and here we can get the details of risk score for every customer, the risk tier, the sentiment label, the top drivers. Like why did we mark this as critical? Okay, because of the negative sentiment. And again we have the low CSAT score. So for example, for the second customer Fatima, we have the plan is standard, the risk score is 87, the risk tier is critical, the sentiment level is negative, The top drivers are the negative sentiment, a low CSAT score, and 44% usage decline. So similarly, we have details for all the other customers. So here we can see, and then we have the risk distribution, like how many customers are classified into critical risk, high risk, medium risk, low risk. We have the risk signal heat map. So here the 0 means it's healthy and 1 means the maximum risk for that signals. So these are the different attributes. So as I previously told that a particular sentiment is not enough, we need all other attributes also, CSAT, tickets, users trend, to identify the risk. And then we have the customer drill down for each customers. So for example, if you go to 0053 Fatima, we have been identified as critical. So this is a transcript summary that the user complained about being billed twice and says support never resolved the last two tickets. So for each, this is a full signal contribution breakdown. This is the sentiment, it's minus negative. Then we have the customer satisfaction score is 2 out of 5. The user's trend has been declined over 30 days. The support ticket volume, she has opened 5 in last 30 days. The billing status is overdue. Okay. So based on all these factors, we are just going to identify uh, whether the risk tier is critical or high. And again, so again we are normalizing it. The reason for this is that the original signals like the CSAT score or the trend may have different formats. So sentiment, for example, ranges from -1 to +1. The CSAT ranges from 1 to 5. Ticket volume again is a count. So for that, that's the reason we are doing normalization. And then these are the weight. For every factor, we have added a weight. This is a weightage for everything. Like here, I have documented it. So for sentiment, we have 35% weight. For CSAT score, 20%. User strength has 20%. Support volume has 15%. Yeah. And then this is AI rational and suggested action. So first we are saying why this has been identified as risk critical. Then we have the suggested action like escalate to a senior account manager for a same day outreach call. Yeah. Similarly, we have for different customers. We have Fatima Khan, then we have Patel. Okay. Like for this high, we can see Aisha Kim. So here also we have giving the reason like why we have been identified as high risk due to low CSAT score and neutral segment. So the customer's transcript summary was short, polite, and non-committal answers and ended the call quickly. So for this we have different suggested action. Like similarly, again, if you see for low and medium risk, and plan is everything. So again, we see why this risk tier is medium. See, it's been flagged as medium due to negative sentiment and overdue notice. Yes. So the risk signal heat map is for all the customers present in the CSV file. Yeah. So again, we can see the risk. So this table again changes based on the risk tier, medium, low. Again, we have categories such as we can even browse files and we can upload the CSV from here. But again, if we select a different categories, like if we select the risk everything like critical and high, but if we choose a scenario where the customer is loud but loyal. So here the Fatima, customer was frustrated about a single confusing error message, but the rest of the product has been excellent. So but she said that the product has been excellent this year. So we can't go and change this risk here to high. So yeah, so the suggested action again got changed that no immediate action needed, continue standard monitoring. So these are the points contributed from sentiment. From sentiment itself, we got 17.5, and then from support ticket volume 2.5, and rest again everything was good. So for example, another, if we take, we have different categories again. Silent risk churn. See, in the sentiment it was neutral, like customer said everything is working and has no complaints, but again the user strength has decreased, the bill stated is overdue, the customer satisfaction score is 5 out of 5, but it has flagged as medium due to neutral sentiment and decline and an overdue notice. We can see the top three attributes. Yeah, so here we can get the ambiguous signal test case and all. So these are the different filters, and yeah, this is the app which I have deployed. So again, some of the limitations would be, there are also some limitations, like the data set here which I use is synthetic, and therefore the current weights are not production calibrated. In production I would validate these weights against historical churn or retention outcomes. Second, the current prototype uses a simplified transcript representation. A production system would aggregate multiple interaction over time. Third, again, the current risk score is point in time assessment. A production implementation could track risk in movement over time. And again, the future scale would be, if this would be taken to production, I would separate the ingestion, scoring, presentation layer. The system could also generate alerts when a customer crosses a critical threshold, and yeah, historical risk scores could be stored so that we can identify whether a customer's risk is increasing or decreasing. So yeah, these are the different things which I would take care of. And yeah, thank you for your time. Thank you everyone.